Well, here we are, first lesson on calculus and specifically limits. We're going to be finding limits of different functions, and we're going to be using a table, and we're going to be graphing functions and finding the limits that way as well. But hopefully you were in class today and you were able to understand a little bit about what calculus is, and so we'll get right into it. The limit of a function, and that's what we have down here. We have this yellow curve here represents the graph of y equals f of x, and you can see there's a specific value of x here along the x-axis. We'll call that c, and then we'll also say that we know that f of, let me find a better color here, we know that f of c is equal to n in this example, and so using calculus to describe what's going on here and using limits, we say that the limit, and how you say this, is the limit of f of x as x approaches c is equal to n. And so this might seem kind of easy to you, and many times, many cases in calculus, you'll find it is actually pretty easy. And we'll get some other examples that'll challenge you a little bit. But anyway, I really want you to just get used to the notation here, and that's what this is right here. This is something new for most of you. That the limit of f of x as x approaches c is equal to n. And what this says, just to elaborate a little bit here, is that as x is approaching c, meaning as x gets closer and closer to some random real number c, we say that the y values are getting closer and closer to some, if the y values are getting closer and closer to a certain number, as x gets closer and closer to a certain number, then we say that this function has a limit as x approaches c. And so that's where we're at right now, and we'll do some examples, and hopefully this will be something that you understand pretty well, and then coming into class you'll be able to look at a graph and be able to find its limit pretty quickly. Okay. The one thing I really enjoy about calculus more than any other of the math classes that I teach is that most of the work is done in your head. Most of the understanding is the problems that you have to do require a lot more understanding versus the work that you show on the piece of paper. So in other words, you get a problem in calculus and you have to look at it for a while, understand what it's being asked, and then you just write down the answer, which is what these problems are a lot like. So you'll be able to see that. So let's look at a couple examples here in which we use real functions. In other words, just instead of just drawing this random curve, yellow curve, and calling it f of x, we're going to use yellow curve here in the first example in the top left, and we'll call this curve y equals x squared. So we know what the graph of y equals x squared looks like, and if we want to find its limit as x approaches 2, then basically what we're doing here is we're saying, all right, as the x values get closer and closer to this number 2, are the corresponding values of x squared getting closer and closer to a number. So we can see that. We can see that the y values, the values of x squared, are getting closer and closer to 4. So we see that the limit is 4. Okay? And then this second example down here at the bottom, as x gets closer and closer to 3. So here we don't have the graph mapped out for us, so we have to know where the x, or what the x-intercept is, and we know that here, with a little bit of work, we know that x equaling 1 means that y is equal to 0, so we have an x-intercept there at 1, and we see that the slope of this line here is 1, and so we go up 1 and over 1, and in other words, when x is equal to 3, we know that y is equal to 2. And so we have this point 3, 2, and again, as x gets closer and closer to 3, the y values get closer and closer to 2. And so no matter how close you get to 3, the y values are still getting closer and closer to 2, so we say that 2 is that limit. Okay? So there you go. We'll cruise over to the next slide. And here we see some things that are a little bit different than what we're used to. We see a hole in the graph and then on the top, and we see a hole in the graph on the bottom, but also a value for c down here in the bottom. So anyway, let's look at the first one, top left. And despite what you might think, here we see that in algebra if we plug in c to this function up here in the top left, we see that the function is undefined actually at c, and so we say that f of c, d and e, or does not exist, or is undefined, however you want to say it. Nevertheless, we still have a limit, because as x gets closer and closer to c, and I want you to understand and keep in mind that we haven't said that x actually reaches c. All we've said is that x is approaching c. And so that's a key word in calculus, approaching. That's something we're going to focus a lot on. And so as x is approaching c, but not necessarily getting to c. In other words, we don't really care what happens when we get to c. What we want to know is, are the y values getting closer to a certain number? And in this case, yes, the y values are getting closer to a certain number, and that number is n. So we say the limit is n. Okay? Even if the function doesn't exist. Alright, so I want to point out here that this is algebra. Okay, and up here, this is calculus. Calculus. Alright? And so it's important that when you're finding limits that you don't let your algebra eyes cloud your calculus eyes. Okay, we'll talk more about that as well. Alright, so let's take a look at this other one. Now you should, again, not look at this through your calculus eyes, but if we do, or sorry, with your algebra eyes, but if we do want to know what the algebra value is, here we say f of c equals, well, we don't even have a y value for that. We just know that, let's say we'll call that b. Okay, and so we say f of c equals b. Alright, well, this is algebra. Algebra. And we don't need to worry about that. What we need to worry about here is what's going on in the calculus, because we're trying to find the limit. So the limit of f of x as x approaches c is n. So the y values are getting closer and closer to this n again. Okay, so those are common letters that we use to describe the limits. Okay, and another way to look at this is by thinking about this as, wow, okay, we're going to totally block out what's going on at that specific value that we're approaching, and we don't really care what it looks like. What happens when we get to c, what we care about is, are these, let me do this in a big thick color here, are these y values getting closer and closer to the same number? And you can see these y values are getting closer and closer to the same number, and that number again is that n. So that's why we have a limit here. So if you block out what happens at c, then you're looking at it from your calculus eyes. Okay, so I'm going to actually pause the video, stop it, and we'll pick up on the rest of the lesson in the next video.